Hey guys, today I'm going to talk about something called conditional probability. So, just to kick it off, we're going to look at an example of probability that we might be a bit more familiar with. So, I've got here a sort of Venn diagram, and there's two sets as we can see, set A, set B. And we might just say set A, that's the number of students who brought an apple to school, and set B, that's the number of students who brought a banana to school for like recess or whatever. And you can see we've asked 40 students total, and the answers are distributed as we can see in this Venn diagram. 10 only brought an apple, 15 only brought a banana, 5 brought an apple and a banana, and 10 brought neither an apple nor a banana. Alright, so if we were asking about the probability of, picking out one of these random 40 students, and we were asking the probability that, well, what's the chance that one of these 40 students, if we picked them out randomly, would have an apple? Well, that's just going to be the number of students who brought an apple to school, so the number of students in this set A, out of the total number of students in our sample space. 15 out of 40, and of course we can simplify that, dividing top and bottom by 5, 5, 10, 15, 20, 25, 30, 35, 40. That would simplify to 3 and 8. There's a 3 and 8 chance that if I ask someone out of these 40 students, there's a 3 and 8 chance that that student brought an apple to school. Great, so that's all well and good. Here's a new kind of probability that we need to know about. This is what's called conditional probability. And well, we see this symbol here. This is what tells us, we're talking about conditional probability now. And the way we read this as, what's the probability of A given B? So this little symbol here, this sort of like, I don't know, dividing line symbol, we read that as given. So what's the probability of A given B? And so what does that mean? It just means, well, what's the chance that we pick a student who brought an apple to school out of, not the sample space, but out of the students who brought a banana to school. So let me just illustrate this point really quickly. So if I was talking about the probability of A, well, that's going to be every student inside this set A, every student inside here, out of this whole sample space. Do you get me? So if I say, what's the probability that we got, what's the probability of A? The way we determine that is we talk about the number of students in the set A out of the total of number of students in the sample space. And so probability of A looks a bit like this. What's green out of everything else, right? So it's 15, 10 plus 5 out of that total of 40. If I were to ask about what's the probability of A given B, well, now let's think out of what? So A given B, so we're only considering options where we achieve a B. Let me start again. So why we say conditional probability, we read this as the probability of A given B. We're looking at outcomes where we achieve an A under the condition that we've also achieved a B. So when I say, well, what options are we looking out of? Like we have this many apples out of this many outcomes. Well, the only outcomes we will be considering are the outcomes given a B. So we're going to be looking not out of the full sample space, but out of all the outcomes in B. So given B, given a student has brought a banana to school, what's the probability that they also brought an apple? Right? So given a student has brought a banana to school, the probability that they've brought an apple to school as well, well, you can see the probability that we have an apple given we have a banana, well, we can see that there's a total of 20 students who brought bananas to school. So given those 20 students who brought bananas, 5 of them brought apples to school. So when we shade the probability of A given B, for example, on a Venn diagram, it looks something like this, right? So we're not looking out of the full sample space like we did in this first example. It's not out of 40. It's out of whatever is given, right? So probability of A given B. If it's given B, then we're looking, in terms of our probability, our denominator, we're looking for our probability to be out of what is given. So it's out of the number of elements in B. Well, there's 5 elements that are A in set B. So A given B is going to be 5 and 20. We can simplify that to 1 in 4. All right, hopefully that made sense. But anyways, just to finish this up, let's kind of express this now. So if we have the probability of A given B, well, we kind of saw that was the probability of our intersection here out of our set B. So it was the probability of our intersection out of set B, right? So if you're taking down notes, box this. That's a generalized formula or generalized kind of equation for conditional probability. A given B, A under the condition we are also B, is going to be the intersection of A and B over B. And that's kind of what we looked at here, isn't it? If you can relate, this expression back to this diagram, well, that's exactly what I'm trying to say here, right? What I shaded in on this Venn diagram, that is the intersection over set B. And just to kind of express this in a different way, well, this is a ratio, probability of this intersection to the probability of this set. It's a ratio. So we can kind of make the connection then that the ratio between the probabilities is got to be the same as the ratio between the number of elements, because it's a ratio, right? So this compared to this, whatever that ratio is, it's going to be the same ratio as this compared to that, right? So we can say that the probability of the A given B is going to be equal to the number of elements in the intersect over the number of elements in the set B. Okay, and box that too if you're taking down notes, please. But I believe that is all. Yes.